By the way, folks, just before Donald starts, next week there won't be any session because of Thanksgiving. Just want to give a heads up. Thank you. Go ahead, Donald.
Thanks, David. Hello, everyone. My name is Donnell D. Smith. I'm a TSP, or Technology Solutions Professional in Microsoft in the data and AI space. Today, we're going to be covering Azure SQL Data Warehouse. So just to go and get started, just quickly, we'll do a couple of recent updates regarding Azure Data Warehouse, and we'll go ahead and get into that deep dive. And then some time, we'll do some demo and then QA. So some recent updates, just for everyone to know, is there's been some recent updates specifically around performance recommendations for Azure Data Warehouse. There's been some enhancements, both the order provides some adaptive cache, so you can kind of be advised when to scale and optimize your cache utilization. Some information that can be retrieved through the Azure Advisor, also some table distribution to kind of help you determine where you need to basically potentially switch to maybe a replicated tables. And then also one more piece with TempDB to get a better view and understanding when to scale and configure resource classes to reduce TempDB contention. I have a picture on the slide that actually has an example of the advisor recommendations. And then another recent update has been on maintenance scheduling. This is currently in preview. And then one more is in flexible restore points. And then I'll get into maybe a little bit of a demo a little bit later on each one of these after we dive in a little bit deeper into Azure Data Warehouse. And just so you're aware, you can always see the updates that are basically coming out for Azure Data Warehouse through the azure.microsoft.com on the updates location. There's a link at the bottom of the slide, and we can provide that information to you as far as that location. You can also get RSS feeds sent to you so that you can actually get those updates as they come through as far as the recent changes or enhancements. So Azure SQL Data Warehouse. What is Azure SQL Data Warehouse? So Azure SQL Data Warehouse is basically a relational platform as a service. It's fully managed. It provides the ability to elastically scale that cloud data warehouse, and it has those proven SQL Server capabilities. Some of the basic things are that it can scale to petabytes of data. It is a massively parallel processing system, or MPP, versus an SMP or symmetric multi-parallel processing system. SMP is more, which you'd be more familiar with a traditional SQL Server approach. With massively parallel processing, we'll get a little bit more into that, but that gives you that ability to scale a query across multiple compute nodes. It has instant on compute scale. It can scale in seconds. But you're going to be familiar with it because it is that relational and query form that you're used to with T-SQL or Transact SQL. It has relational batch processing. It provides compatibility for full hubs and spoke support so that you can actually have like a Azure Data Warehouse as your hub, and then you can set up your spokes with analysis services or Azure SQL DB as your data marts, etc. It's built for large-scale analytics. And it also provides that market-leading price and performance. So what do we mean by it's a fully managed platform as a service? So it is a cloud data service, right? But it provides that ability to kind of look into there, and it takes care of things for you from, like, for instance, your backups, and as far as the provisioning of resources. So you go in there to the portal and you set up that provisioning, but as far as the actual infrastructure, that's handled for you, right? There's a lot of extra support that it provides as well. We'll kind of get into that a little bit as we progress through this presentation. But keep in mind it allows you to scale those resources on the fly, right? It does separate storage and compute. There are existing tools that you can actually utilize to do various tasks. The Azure portal is great for you to be able to go in there and use a UI to basically go through and both scale your environment, look and monitor your environment to see how it's running, and do other tasks that you may need to do. It can deploy within minutes, and you can also scale up within the same time frames. Now, what is Azure SQL Data Warehouse good for, right? It's good for analytic workloads. So where you're storing large volumes of data, right? Large volumes of data. It's great as a single location where you can kind of consolidate your different data sets. It's great for basically transforming and aggregating your data. It's great for, pre-analysis across large data sets. And it's great also from that ad hoc reporting characteristics. And we'll get into a little bit of concurrency as well and how that factors in. And this is all using the simple SQL constructs that you're familiar with. So again, if you're familiar with Transact SQL, T-SQL, within SQL Server, you will be familiar with Azure SQL Data Warehouse from connecting and running queries against it. So what are some aspects of, okay, well, if those workloads are great for Azure SQL Data Warehouse, what are things that we should possibly look at as not being necessarily best suited for Azure SQL Data Warehouse? When we talk about workloads that are not really what you would aim on for a data warehouse, those are usually related to operational workloads, or what we call OLTP workloads. And those are specifically related to high-frequency reads and writes, a lot of singleton select statements. Any kind of singleton statements are not really what you should be looking at or geared towards that set. And then a high volume of single row inserts as well. I think I saw a question there as well. So can you give a high-level overview of the difference between data warehouse and data lake? So a data warehouse, right? And think of the Azure SQL Data Warehouse is going to be your relational data system, right? So it's basically pulling in data that's relational in form. Your Azure Data Lake is going to be more that mass storage of semi-structured, unstructured data that you can then pull and use in different ways. And you can actually use that data lake, right, as a source for data that you would pull into Azure SQL Data Warehouse as well via PolyBase or something of that nature, right? You can also use Databricks, and then to access and run ETL on against that data that's stored in Data Lake, and then load that into your Azure SQL Data Warehouse as well. But from a high-level standpoint, think of it more as your Azure SQL Data Warehouse is that relational storage location, right, of all your data sets. And then Azure Data Lake is more as a mass storage location for different data sets that are both relational, unrelational, structured, non-structured, that you can then utilize in various forms through various solutions and tools. So let's take a logical overview look at Azure SQL Data Warehouse and how it actually works. So from the underlying concept of your Azure SQL Data Warehouse, you have basically a bunch of different storage locations, or 60 basically distributions of storage. And those are separate storage locations that you can actually utilize. On top of that, you have what's known as your compute nodes, and this is all scalable. So your compute nodes then point to various storage locations to be able to run your queries. Above that compute node, you have your control node. And basically, your control node is basically your entry point into your Azure Data Warehouse, right? That's basically what controls the query that's being run, and then basically sends it to those different compute nodes for it to actually be able to run. The number of compute nodes is based on your tier or service tier that you actually specify, what we refer to as a SKU. And then that number of compute nodes then maps to the underlying storage. Again, the storage is basically 60 distributions. And as far as when you scale your tier or your service level, that basically allocates multiple more compute nodes until eventually you get to like a 60 to 60 or 1-to-1 relationship between your compute and storage up to that amount. Again, your control node is where your data comes in, and then it processes against that compute. So this is just kind of showing you an example of that, and then that breakdown of that compute. Now, when we look at this a little bit more detailed, right, we have basically two different forms. We have Gen 1 and Gen 2. So this is often referred to as the optimized for elasticity and optimized for compute. Again, we still have that similar architecture of the control to compute to a remote storage location for that mapping of data. But you'll know in Gen 1, between Gen 1 and Gen 2, there is a difference in caching at the compute node, right? So this is basically Gen 1, or the optimized for elasticity, what the traditional structure would look like. But then we get into that Gen 2, where we have the non-volatile memory, the SSD within the compute nodes, as well as that caching layer that allows us to take frequently used columnar data and then move it to the compute node for quicker data retrieval. This graphic just kind of shows you that movement of that data to the cache so that you can have that quicker access. So basically, when that query comes in, as this demonstrates, it comes in, gets to the control, maps to those computes. The computes pull back from the storage. That data is then pulled back up to the compute, which passes back up to the control, gives that result set back to the session. Now, if you dive a little bit deeper into those distributions of data, we have basically different forms of distribution, right? Or different ways that data can be set on disk or to the storage locations. We have a couple of more predominant ones are the round robin distribution, and then we have hash, right? We also have replicate. Round robin is going to be as this data comes in, it's basically going to go through and say, okay, well, let me map that data to the distribution sets, right? The distribution storage locations, and using its own picked item. So basically, it just keeps mapping that data. A hash distribution, you pick the key, right? And once you pick that key, that key determines, okay, where is that data being stored? So here, there's an example. There was a 01 key, 02 key mapped to the two different distribution locations. And a third one, that when you get more data related to that first key, that goes back to that same distribution location. While in round robin, it's just kind of mapped to in a round robin approach, right? Just maps it straight to the disk versus the key or the distribution or hash. The hash approach is usually best geared towards larger data sets, right? Because you have less data movement if you can kind of target their query against that data set. And just keep in mind when you're working with hashes and round robin that you want to be able to, when you do your joins, you want to make sure you keep your hash keys the same based on your joins. So this kind of goes back into a little bit into that approach of how the client actually comes into the control node. The DMS is the data movement service. And then there's also the parallel loading with PolyBase. So PolyBase is a tool you can use to quickly and efficiently load your data into your data warehouse. You can also use it to write. Now, it works in a similar approach if you're using PolyBase, right? You have your control nodes, you have your compute nodes that map back to that storage location, but it can parallelize that load so that you can actually distribute it across compute nodes. So let's say that you had a text file that you wanted to load, and it was uncompressed CSV. Now, what it would do is it would take that file and try to stripe it across your compute nodes to be able to have quicker upload of your data to your storage location, underlying storage. So now with Azure Data Warehouse, when we mentioned sizing or tiering or SKUs, that relates back to what's called as a data warehouse unit or DWU. That DWU basically encapsulates or brings all together your resources that are used for your Azure Data Warehouse, right? That's going to be more geared towards your memory, CPU, your I/O. Those characteristics of resources are kind of taken in and then put in a way that masks it for you, makes it easier for you to be able to utilize by just selecting one data warehouse unit or DWU. As far as snapshots or backups, which is a question a lot of people often have, rather than saying backups, what you do is you get a snapshot. Now, you get a snapshot of your Azure Data Warehouse within specific intervals. So that frequency is set for 4 hours with a default retention of 7 days. And then you have your RPO of recovery point objective of basically 8 hours. You also have geo-redundant backups. Now, geo-redundant backups is basically you have one within a 24-hour period with that 24-hour RPO. You basically have that one geo backup. Now, to keep in mind that as far as that geo backup, you do have the enabled or disabled option. So that's something that you can turn on or off. You don't want to leave it on, it's on by default for Gen 2. Within Azure Data Warehouse, one of the things that we mentioned is when you're running a query, it runs against it and you have a certain amount of concurrency. So concurrency is basically a combination of two different aspects. One aspect is the number of concurrent queries, which is what people often think of. How many queries can I be running at the same time? But there's also a second aspect, which is known as concurrency slots. Concurrency slots is dictated also by your tier level that says how many amount of parallelism, basically, or how much memory can I be utilizing across my data warehouse for the queries that are actually currently being run. That also scales as your tier level scales up. In this example, which is a Gen 1 tier structure, you can see where the number of slots scales up as you basically increase your service in tier level. Looking at it from a Gen 2 perspective, just looking at this, and you can find this online through the online documentation, is you can kind of look at, okay, if I was looking at Gen 2 with static classes, I have my maximum concurrent queries. It starts off, right, with this 32. Now there's a new one with Data Warehouse 500C, which I don't have in this particular slide, but that starts off with 20 maximum queries and 20 for your concurrency slots. As you scale up, though, you have more maximum concurrent queries. How many queries can be running at the same time? Now, this is not how many queries can be queued, which is also a different measure, but this is the maximum concurrent queries that can be run at one time. So if you're looking at it from that perspective, once you scale up to like a 6000C service tier, you get up to that 128 concurrent queries. But let's take a look into the concurrency slots. So that's another thing that has to be looked at, right? So with concurrency slots, right, this maps also directly to the amount of memory per class. Basically, it says, okay, I have each query that runs has a certain number of slots. That's the maximum concurrent slots that I can run with the combination of classes for this service tier. At this service tier of 1000C, it's 40. That goes all the way up to 1200 for a 3000C. Now, you're probably wondering, well, what's the difference and why should I even look at that? If you look across at these different static resource classes, which is what you would assign to your users to run queries, the resource classes lets them know which resources are available for them to utilize for those queries that they choose to run during their session. So like a static RC of 10, well, everybody gets one slot or concurrency slot that they can actually utilize for that class, right? So if someone says, oh, I'm running at a static RC of 10, they get, oh, one concurrency slot, which is great because now you can have up to 40 concurrency slots, right? Which means you can reach that maximum 32 concurrent queries. But now let's say you said, okay, well, I want someone to have the maximum number of concurrency slots available that they can use, which would take them up. So said, oh, I'm going to put them at a static RC of 80. Well, if I put them at a static RC of 80, that says, well, I can use up to 32 concurrency slots. Well, if this person uses 32 concurrency slots, and I have one more person at static RC 60, they have 32 concurrency slots. Well, even though I can run a maximum of 32 concurrent queries, 32 plus 32 puts me way above my 40 concurrency slots, right? So that would basically send other queries into a queuing state because there's not enough concurrency slots available to sustain those queries run by these various users at these various resource class levels. So like, for instance, if they had about, a whole bunch of people running at 2, that's great because you can have up to, 20 of those running at 2 concurrent slots to match 40, but then you would be capped at the 32 maximum concurrent queries. So always keep in mind that it's a combination of maximum concurrent queries and concurrency slots that have to be taken into account. So going back to some of the recent updates, and the reason why I kind of want to come back to this is I wanted to show you a few of how these actually work, because this can be some important points, especially with this one right here, the flexible restore points, which allows you, because what's happening a few slides ago, I mentioned that those backups occur for you. They're automatic. So what happens is during those regular intervals is those snapshots are being taken for you. But what happens is, say you said, okay, well, I want to be able to do a rollout of a big production release at a specific time interval. And you said, okay, well, I want to make sure that we can take that snapshot or lack of better words, a backup at that specific time. Well, how can we do that? One way is to use these flexible restore points. So if I look at my Azure portal, and then I go in here. So this is a sample data warehouse that I created, right? It's a fictitious company that was basically provisioned. And if you ever do some workshops, you'll probably see this as part of one of the workshops that you'll see of what you would provision. So with the flexible restore points, one of the options now is this one right here. You can create a new restore point. When you create a new restore point, you basically go in, you gave it a name, say my restore point test, whatever you want to name it, and then you hit OK. What that did is that fired off a snapshot, and I can see that through the Azure Data Warehouse. One way I can see it, of course, is by running a query against it. So if I run sys.pdw_loader_backup_runs, and I don't look at the scheduler returns, I can see those different restore points. You can see one that I created earlier as a test, and you can see this one here. This one is currently running. You can see that it's running. It's almost done at 99%. This one is completed. The second one that I ran earlier, and that one finished. It'll give you this various information that you can then utilize within your portal to do a restore from there. So one of the questions that someone asked is, if someone in a higher class, RC80, is not logged in or running queries, can the user in the lower class utilize idle slots? Yes, they can. So that's the slots that are being consumed versus slots that are available. So let's say that you had someone at RC10, a whole bunch of people RC10, and you had one at RC80. If the RC80 user is not running any queries, then the ones at RC10 can utilize all those concurrency slots they can then be available. So it's only what's running at that point in time versus their class alone, if that makes sense. So the answer to your question is, can the user in lower class use idle slots? The answer is yes. Okay, so going back to this one here, going back also to this presentation. So that was like the flexible restore points. Now, as far as being able to use those flexible restore points, once I have that, right, now that we already saw them there, I can actually go in and I can actually do a restore if I so choose to use those flexible restore points. And then right here, you're going to say restore point types. We can use automatic, which is the system generated ones, or I can say user defined. And when I say user defined, now I can come in here and I can say, well, which restore point do I want to use if I need to go back to that backup, or snapshot is really the appropriate term. So this one is the one that we just created. This is the one I previously used. Again, if I look in here, you can see that the other one was completed. It tells you the time elapsed and it's completed 100%. So I can actually utilize this one to basically go through and then say, okay, I want to create use that as my base for my restore. It won't overwrite your existing Azure Data Warehouse. It creates a separate Azure Data Warehouse that you can then utilize. Notice that from here to the database name that you specified. So that's the flexible restore points. Another one, go back to this one, is this maintenance scheduling. Because another thing that comes up often is people want to know, oops, okay, I hit the wrong button there, is when I go, how's my maintenance actually scheduled, right? So right now you get notifications, you can see upcoming pending maintenance, but one thing you're not able to do on a daily basis is be able to say, okay, what do I want to set my schedule for? So one of the things that's in preview currently is this maintenance scheduling. So again, this is in preview currently, but if I come in here and I go to any of my Azure Data Warehouses, in the settings, I have this maintenance schedule. Within maintenance schedule, I can specify, again, this is in preview, but it would allow me to specify a primary and a secondary windows that I can actually set for my maintenance or my scheduling of when I want my maintenance to occur on my Azure Data Warehouse. Now, this aspect of it, right, is a great feature. So when someone says, well, I want to make sure that I try to hit these particular intervals, right? So that's when they're going to target us as far as being, I want to make sure that I want to target this interval or this time frame for my actual patches that are being pushed out, or my enhancements or my updates. You can actually see this if you wanted to, in case you haven't looked at it before. There is a screen that you can go to called Service Health. And then I can go into my events here. Now I don't have any planned maintenance currently, but I'm going to go look at my health history. So I'm going to go back just to show you what it would look like for some maintenance aspects. So if I go in and look at my planned maintenance, you can see that I had one for one of my Azure Data Warehouses. It was done 3 days ago. You can actually see the details on that maintenance. And you can also set up alerts, right, depending on how you want to be alerted of these maintenances that are going to occur, aside from you scheduling it within the preview. But this allows you to see, okay, what actually took place. So like in this example, I can see that I had some maintenance that occurred against one of my data warehouses on 11/13, and it shows me that time frame and the impact. All right, so that's kind of some of the demos and a short presentation on Azure Data Warehouse. I believe does anyone have any questions they would like to ask for a Q&A perspective? Anything related to Azure Data Warehouse? If not, I can go back into a few more aspects within the demo.
Yeah, please feel free to unmute yourself if you have any questions.
Yeah,
or post in the IM. Go ahead.
Amber here. So if a user in a lower class has his query running, will it run in the same amount of time every time that particular user runs a query, irrespective of other users running queries? Will it take the same amount of time, or it varies based on the other users running queries?
So the amount of time is if other users, and that's where it becomes important within that resource class. Let's say, for instance, you have a lot of users that are hitting the database and they consume those resource class, what will happen is your query within your resource class, right? You start to run your query, it could get queued while it waits for the resources to be, the concurrency slots to be released, or the maximum concurrent queries to be released, right? So that you can now run your query. So from your perspective, if the concurrency slots are consumed, then you run into basically a queuing situation. So it'll make it look like it's running slower, but your query is not actually taking longer. It's just that you're waiting for your slots to be available so that you can run your query. So it would, like I said, it would make it look like it's running slower, but it's not necessarily your query is running slower. You could go in there into the actual metrics of your information and look at how long it takes for that query to run. But the idea is that it's really geared towards whether or not you have enough concurrency or available slots, and that's really tied to memory, right? So how much memory you have is available. Think of it in a traditional approach. If you were on your SQL Server and you were trying to run a query, if your resources get tapped out, then you can't run your query until those resources become available, right? When those resources become available, then your query can run.
Okay. Yeah. Thanks.
You're welcome. Are there any other questions? If there's not, then I can show you real quick some way that you set up the AAD, the Azure Data Warehouse.
Hello, can you hear me?
Yes.
So my question is regarding choice between data warehouse versus database. So I have a customer who's starting off and their data set might be only be few hundred gigs. So from what I'm reading, there's a guideline, usually you got to have at least 250 gig data to kind of make use of MPP. Any kind of thoughts around that?
Yeah, sure. So there's multiple points to look at when you're looking at your data sets, your database. So at a lower size of database, you may not be able to make the maximum utilization of an MPP architecture because you do have that overhead of the splitting out of your query, right, across the compute nodes, the data retrieval, and the data management service that's going to potentially look at your data, right, and then recombine it to send it back to their calling session. Now, there's another aspect of that, right, which is also your distributions. And the reason why is because to get the maximum benefit, right, let's say you're going to use a column store, a columnar format for your data storage, right, to get that maximum compression and efficiency and speed and performance. When you do, right, depending on the size of your the table, right, the amount of data that you have, as it spreads that across your distributions, if there's not enough set for it to close that store, it goes into what's called a delta store. So you don't get that full compression, which can impact your overall performance. In other words, you could get better performance. You're not necessarily getting bad performance, but you could get better performance with a larger data set in that kind of a scenario. Data warehouses are really geared towards those extremely large data sets, right? When you're getting into terabytes of data, it's when it really starts to shine. Petabytes is awesome.
And when we talk about these sizes, are these the raw sizes before loading into database or like data warehouse, or the compressed data warehouse size after loading?
Look at it from the raw size, because when it after it loads it, it's going to load it into that columnar to compress it. But in order to compress it, it has to have enough rows to compress, right? So it's going to look and say, okay, how many rows do I have to be able to utilize for that? Which really gets not just into the total size of the database, but also the size of your individual tables and your row sets or data sets within those tables, right?
Sure.
And you just want to make sure you kind of hit it and tune it for that maximum efficiency, right?
Sure. Makes sense. So like they will be adding more manufacturing plants, but it might take a while, maybe a year or two. So starting with database, Azure SQL database, and then having a path to Azure SQL Data Warehouse in long term, is that a kind of a good idea? Because I don't see any point going with data warehouse to begin with, but eventually we might have enough data to kind of make use of it.
There's going to be a couple of points with that. So the first aspect is going to be how quickly are you going to be growing your data set, right? So how quickly will that data set actually be expanding, or will it be ballooning extremely quickly, where you're going to be ramping up very, very efficiently, very fast to be able to utilize and fully scale? And then also, how quickly do you want to be able to utilize those returns and those row sets, right, to get the maximum efficiency? So you could be where you would be fine running it within Azure SQL DB, Azure SQL Database, or Azure SQL Database, either single or managed instance, right? And then eventually moving to a data warehouse solution as your data sets grows and becomes at a much larger scale. When you're getting into like over, say for instance, you were getting to a point where you're over 4 terabytes, you're running in an Azure SQL single model, and you wanted to basically be able to take advantage of that multi-parallel processing architecture, massively parallel processing architecture. But you can potentially move it in there now, depending on the performance needs of your query currently, right?
Sure.
So I would say it kind of depends from that aspect of looking at the overall size, the needs, and what you were looking to achieve, both short term and long term.
Sure. Okay. Thanks. That helps quite a bit.
You're welcome.
Amber, yeah, sorry, one more question. What kind of schemas are suitable for SQL Data Warehouse? Like you could have a star schema, Snowflake, or a normalized schema, but that could involve a huge number of joins. So is a workload, I mean, does the joins perform if you're joining like, 10 to 15 tables in a normalized schema, or it's preferred to have a kind of a simpler star schema on SQL?
Well, there's a couple of points there. Star schemas work great, Star and Snowflake schemas, because of you normally have like a larger table, right, with a couple of different smaller sets or data sets that you actually pull in together. One of the benefits of that is when you're coming up with your architecture and your design, you can replicate some of your smaller tables, which basically, when you do a replicated distribution, what it does is it sets those tables within initially almost like a round robin behind the scenes, but then as soon as they're accessed, it loads them into those cache. So there's basically a copy of it at each compute node for faster retrieval, especially as you join it with that much larger table that would be like a hash distribution, right? So you don't have the data movement service doing a lot of data movement behind the scenes. When you go into more of a traditional relational look and feel where you have multiple tables and multiple joins, one of the issues you can run into is depending on the ways of those joins, especially on larger data sets, you can have a lot of what's called data movement that's occurring behind the scenes. If you look at your metrics and your query when it's processing, you'll see the data movement service, DMS, like churning, right? Because it's trying to move the data around to basically pull this data together. That happens if you're joining off different hash distribution keys, or if you're joining without those replicated tables on a massively large tables, right? So you have to make sure that they matches up to get the most efficient performance. Now with the instant data movement, it's drastically improved it, so it's not as you're going to get good performance, but you could get optimal performance, right, and get the best performance by making sure that your design of your data warehouse kind of falls in those realms of how to make efficient usage of your data to prevent massive amount of data movement.
Okay. Yeah.
Any other questions? I know there was one online, one person typed in the chat, if you can talk about Azure Active Directory and about the new GA low-level security. So there was a question there. With Azure Active Directory, I know we don't have a lot of time, but I'll go ahead and dive into that if I can real quickly. So with Azure Active Directory, first thing to keep in mind is it's not the same Active Directory you have at a Windows level, right? So the authentication is handled slightly differently. Now, the Azure Active Directory can sync with your Active Directory, and there's mechanisms that you can do to set that up. What Azure Active Directory does is it allows you to utilize your Azure Active Directory login to authenticate to your data warehouse. Setting that up is actually quite simple. Basically what you do is when you go through to set that up, you basically have on the server, you're going to have an Active Directory admin. So you go in, and this is already tied to your subscription. So it's the subscription that wherever you're actually in within your subscription, the Azure Active Directory utilizes is the one that it's going to tie to. So you go into your Active Directory admin on the logical server. Remember, this is not a physical server, it's a logical server. So you go into it and you basically set that Active Directory admin, and you set the admin. In my case, it was my account within Microsoft. Once I've actually set that, then I can go in and then create users that are Azure Active Directory users. Once I do that, then I can go through, and as an example, let me move this over here. When I want to connect to it, and I've already opened the firewall to allow me to connect, I can go in there and say, Active Directory, use my login, my current login, and then connect to my Azure Data Warehouse pretty efficiently. So that's basically how you would actually set it up and be able to use Azure Active Directory. I'm not sure if the question was more wanted a little bit more in detail, but that's basically the idea and the concept behind it. Oh, you're welcome. You're welcome, Pedro. Now, Naveed, I know we're a little bit over on time. Are we okay on time?
Yeah, we are fine, man. I mean,
Okay.
we're recording it, so if anybody who have to drop off, they can, watch the recording. So
Okay.
I don't see any other questions, so I think we're good.
Yeah,
Anybody
sorry, one more. So for security, I'm assuming you can do more granular level security where you could set up users in different security groups, and some of them could have insert access, some of them on read-only access. Outside of AD, you can set up more granular database security, right?
Correct. Yeah, you can set up more granular security outside of AAD. You also have your traditional like SQL type login. So you could use either that login, those type of login or that formatted authentication, or your AAD. But that's separate from the more granular security that you're talking about to give people access to objects, to give people different types of rights within your Azure Active Directory, whether it be DB Manager to be able to go there and create, or what can they actually do. So that's you do have that more granular level security that you can use outside of the higher scope. Yes.
And does it support user-defined functions like UDFs?
So user-defined functions within Azure Active Directory. Give me 1 second. Let me pull this up real quick because.
No, in the SQL Data Warehouse, like you could have stored procedures, and could you define user-defined functions?
Yeah, let me pull up something for you real quick. Give me 1 second. Let me pull this up. Hopefully this will pull up.
So because folks who are migrating from Teradata or Netezza, they could have stored procedures and
Yeah, and they would want to have views, stored procedures. So like if you wanted to go in there and create them, right? You can go in there and create like whatever you need to be able to create, right? So you can go in there and you can create stored procedures within your Azure Data Warehouse. You can create views and such. You have this, some similar functionality you would have within Azure SQL DB to create those functions, to create those views, stored procedures. Let me see if I can create a sample real quick for you to kind of show how that works. But as far as the ability to create the objects that you would be able to need, you can create those within Azure Data Warehouse. Let me see if I can pull up an example. I thought I had a script here ready to go, but I actually don't have a script ready for that. I apologize. Let me see if I can pull one up for you real quick, but I thought I had a script ready to go for that, but I actually didn't have a predefined script to go. But the long and short of it is yes, you can. So hopefully that answers your question.
Yeah, and T-SQL, so stored procedure running on SQL Server, is it 100% compatible with SQL DW, or there are some differences?
There's going to be some differences. A lot of your differences are going to be more geared towards your DMVs and other stuff, but it's not 100% compatible. Like, for instance, you don't have all the data types as well as you would have with Azure SQL DB. So
Okay.
there are going to be some differences as far as what you can actually run both from your T-SQL and your data types. Does that work for you? And also DMVs, right? Because you're not going to have the same set of DMVs. Some things are completely different. You're going to have a lot that are PDW related. So you'll see ones that are more geared towards PDW versus the traditional approach. So a lot of them have that same, PDW underscore kind of look and feel for a lot of your DMVs. Not all of them. Quite a few are available to you that you're going to be familiar with, but you would want to go online and look and see which ones specifically, if you're looking for specific ones, because they don't all match up.
Okay.
Thanks, Donald. Thank you very much, man. Really appreciate it.
You're welcome. Is there any other questions or?
Thanks, folks. Just a reminder. Yeah, go ahead.
So in my case, there will be frequent data loads from on-premise, like every few hours or so, and they might not be as big. So that can, if the frequent data loads are not good, that kind of messes up the column store index. So what's your recommendation on that? Like if we want data becomes available every hour, but it's only like 50,000 records or 20,000 records, and they want to see some reports coming out of data warehouse by all the data aggregated or collected at that point. Do you think, do we look for some other solution, or is there a way to kind of handle that well in the data warehouse? And we will have some dashboards in Power BI which will be hitting the data warehouse or through analysis services. But the concern here is now smaller loads every few hours, which is, from my reading I have done, it's not good for data warehouse performance.
Yeah, it's not optimal for sure. It's more geared towards basically queuing that up and then being able to load a massive amount of data together at once to get that optimal compression and utilization, especially with those columnar formats.
Okay.
So optimally, it's not optimal.
Okay.
Could you run those in, right, and then load them? You could, and then kind of queue that up into a staging table, right?
Yeah.
And then either using then CTAS that in, or which is usually your, a really great approach to make sure you get that compression that you need, but it really depends on the size of your tables, etc. Basically queue that up for those loads to be able to utilize them, and then load them as a part of an end of the day process would be one solution. There's different ways you can approach it to kind of work within the confines to get the optimal performance and the optimal compression. So you can still do it. I wouldn't say necessarily it's not you can't use data warehouse. I would say a lot depends on the amount of data and then providing a right architecture that you can then utilize as part of your loading processes to stage that data and then optimally reload it or CTAS it as necessary or as needed to get that compression.
Okay. Thanks.
Yep.
Thank you, Donald.
You're welcome.
And guys, everyone had a great day and happy Thanksgiving.
Thank you, Naveen. Happy Thanksgiving.
Bye-bye.